Alright, so this is Mrs. Conway. We are going to review for your Unit 5 Topic 1 assessment on matrices. Before we get started, Andy wanted me to give him a shout out, so you better be getting 100% on this quiz tomorrow. So first of all, we're going to state the dimensions of each of these A, B, C, D, and E matrix. So this one has, matrix A has 2 rows, and it has 2 columns, so therefore matrix A is a 2-row by 2-column matrix. Matrix B is also a 2-row by 2-column matrix. Matrix C is a 2-row by 1-column matrix. Matrix D is a 1-row by 2-column. And finally, matrix E is a 2-row by 4-column matrix. Square matrices are those that have the same number of rows and the same number of columns. So if we're looking at all of these dimensions, we know that matrix A and matrix B are both square matrices. My row matrix are ones that just have one row basically in them, and so my row matrix is matrix D. My column matrix is one that has one column, so that would be matrix C. And finally, I'm looking at element 2, 3 in matrix E. So if I look here at matrix E, row 2, column 1, 2, 3 would give me that element, which is equal to -2. So those would be the answers for number 2. Now, getting into calculation. For addition, if you remember from our foldable, you would know that both matrices that you add have to have the same dimension. So if I look at matrix A and matrix B, they are both 2 by 2 matrices, so I know that I'm going to be able to add them. And then to add them, I'm just going to add element for element. So I'm going to take my matrix 2, -4, 1, and 3, and then I'm going to take matrix B, which gives me 4, -1, 2, and 0, and I'm just going to add each element that corresponds to the other one that corresponds. So for matrix A and B, I'm going to take 2 plus 4, and that will give me 6. And then I'm going to take -4 plus -1, and that gives me -5. Then I'm going to take 1 plus 2, and that's going to give me 3. And then finally 3 plus 0 will give me 3. And that will be my result matrix of A plus B. Alright, now I am going to multiply the scalar 3 times matrix B. So remember, my matrix B was the same one that I added over here. So I'm going to take 3 and I'm going to put it right outside of that matrix B, and I am going to just multiply 3 times each element in that matrix. So that means I'm going to do 3 times 4, which will give me 12, 3 times -1, which will give me -3, 3 times 2, which will give me 6, and 3 times 0, which will give me 0. So for that one, it's just multiplying 3 by each element in my matrix. So now I'm going to multiply A times C. Now for these, remember, to multiply, the number of columns in the first matrix has to match the number of rows in the second matrix. So if you look at A and C, matrix A was a 2 by 2 matrix, and matrix C was a 2 by 1 matrix. So what you're looking for is you're looking to see if this number of columns matches this number of rows. And since they match, I know that I'm going to be able to multiply them, and my resulting matrix is going to be 2 rows by 1 column. So I'm going to have 2 rows for my final answer, and I'm going to have 1 column. So let's go ahead and set this up. So matrix A is 2, -4, 1, and 3, and matrix C is 4, 3. So these are the two that I'm multiplying together. Okay? I know my resulting matrix is going to be 2 rows by 1 column, So I'm going to set up just some empty brackets that would give me room for 2 rows and 1 column. Okay? Now, to do this, what I like to do is I like to look at my rows, because again, remember I'm multiplying the rows in this matrix times the column in this matrix. And then I'm going to add those values together. So I'm going to start by multiplying 2 times 4, which gives me 8, and then negative 4 times 3, which gives me negative 12. Then I'm going to add those together. So I'm going to say 8 plus negative 12 gives me negative 4. Okay? Now I'm going to take the second row and multiply it by this first column and then add those together. So 1 times 4 is 4, 3 times 3 is 9, 4 plus 9 is 13. So my resulting matrix is going to be negative 4, 13, and again it's 2 rows and 1 single column. Okay? Alright, number 6. When I see bars on both sides of my matrix, or both sides of this array of numbers, these do not mean absolute value. Okay? These mean find the determinant. Okay? So that's what we're going to find. We're going to find the determinant of this matrix. To do that, it's kind of a cross multiplication problem, and then you subtract. So I'm literally just going to multiply 2 times 3 and subtract 1 times negative 4. So that will give me 6 minus negative 4, and 6 minus negative 4 is actually 10. Now again, this whole page that I'm doing here is a no calculator page. So you need to know how to do all of these operations without a calculator. Okay, so non-calculator. Make sure you know how to do all of this math without a calculator. Okay? Alright, let's go on to our next one. Now we are multiplying A times E. So let's check first to make sure that this is even possible. So if I look at matrix A, that is a 2 by 2 matrix. And if I look at matrix E is a 2 by 3 matrix. So again, we have to ask ourselves, does the number of columns in the first matrix match the number of rows in the second matrix? And since they do, I know that my final matrix is going to be a 2 by 3 matrix. Okay? So we're going to set this up. We're going to put A first, A, and then we're going to multiply it by E times matrix E. And matrix E is negative 3, 2, 0, and 1, negative 1, and negative 2. Alright, now we did this one in class today. But again, remember my resulting matrix is going to be a 2 by 3. So it's going to be 2 rows and 3 columns. So I'm going to leave some open brackets so that when I'm doing my multiplication, I have some space to put them in. So again, I'm going to highlight the rows of my first matrix and the columns of my second. So I'm multiplying rows times columns. So that's just what I like to do to kind of get the problem set up for multiplication. So I'm going to do 2 times negative 3, which is negative 6, and then negative 4 times 1, which is negative 4. Negative 6 plus negative 4 is negative 10. Okay? I'm going to repeat that process for every row and column. So here, 2 times 2, negative 4 times negative 1, add them together, you will get 8. Same thing, 2 times 0, negative 4 times negative 2, again I get 8. And then do this, go on to the second row, and then multiply by each of the columns to repeat that, and you get 0. 1 times negative 3 plus 3 times 1, that's 0. 1 times 2 is 2. 3 times negative 1 is negative 3. 2 plus negative 3 is negative 1. And then finally do that with the last row and the last column, and you'll get the value of negative 6. All right, A times D. This is not possible. We're going to call this undefined. And that is because the columns in matrix A, which is a 2 by 2, do not match the rows in matrix D, because that is a 1 by 2. So again, these two numbers do not match, so it is not possible. Okay? B plus D, again, this is again undefined. And that is because matrix B is a 2 by 2 and matrix D is a 1 by 2, and because they are not the same exact dimensions, I cannot add them. Okay, so that is not possible. Alright, B minus 2A. So this means I'm going to take matrix B, which in this case is 4, negative 1, and 2, 0, and I'm going to subtract 2 times the matrix A, which is 2, negative 4, 1, and 3. So remember, this is a scalar value. And what I'm going to do is I'm going to first multiply the scalar by each element in that matrix A. And then I'm going to do my subtraction. So I'm going to take first and just bring down matrix B. And then I'm going to distribute, basically, that 2 inside this matrix. So 2 times 2 is 4, 2 times negative 4 is negative 8, 2 times 1 is 2, and 2 times 3 is 6. Now, if you distribute a negative 2, that's fine. That's just going to change this to a plus. I'm going to keep it the minus and just distribute the 2, and then do subtraction for my final answer. So here I'm going to do 4 minus 4, that will give me 0. Then I'm going to do negative 1 minus negative 8. That's actually negative 1 plus 8. So that's going to be 7. And then I'm going to do 2 minus 2, which is 0. And then finally, I'm going to do 0 minus 6, which is negative 6. So this is going to be my final answer for number 10. Alright. On to inverses. So to find inverses, remember you have the formula 1 over the determinant, and then you switch A and D, and you negate B and C. So that's the process I'm going to use for this one. So I'm going to take matrix B, and I'm going to find the determinant first. So that's going to be 4 times 0, and then minus 2 times negative 1. So my determinant is going to be 0 minus negative 2. Then I'm going to switch the positions of A and D. So this is going to become 0, this is going to become 4. And then I'm going to negate the 1 to make it a positive 1. And I'm going to negate the 2. So this is your new matrix. So really you're multiplying 1/2 times that matrix 0, 1, negative 2, 4. Now you can leave these as fractions if you'd like, okay? Or you can simplify them into decimals. It's really up to you. But in this case, 1/2 times 0 is 0, 1/2 times 1 is 1/2, 1/2 times negative 2 is negative 1, and 1/2 of 4 is 2. So this is going to be the inverse matrix for matrix B. Okay. Alright, now the inverse matrix for matrix A is again using that same process. So it's going to be 1 over 6 minus negative 4, the determinant of A. I'm going to swap A and D, and then I'm going to negate B and C. And now just multiply. So that's going to be 1/10 times 3, 4, negative 1 and 2. And then my final answer, I'm just going to leave all of my entries as fractions. So 1/10 of 3 is 3/10. 1/10 of 4 is 4/10. You can leave them unsimplified. 1/10 of negative 1 is negative 1/10. And 1/10 of 2 is 2/10. And again, you can simplify those fractions if you want to, but that's not a requirement in this case. Alright, so I'm going to make another video for the rest of the review, so look at my next video.